Hey, everyone. Can you hear me okay? Too well? Great. I'm very excited to be here. I think everyone is really enjoying the in-person interactions, and so I'm definitely part of that group. I know this is the last talk of the day. You know, we had some amazing lunch, and so I don't want to make people online jealous, but it was very good. Some great croquetas and other great food here. Thanks everyone so far for all the talks and the panel. I think that I really enjoyed listening to those and hearing about what's going on in the field. And you know, I really just missed this, so thanks everyone for being here. So what I want to talk about today, I don't know if this, there we go. I want to talk about stateful applications in Kubernetes. And my focus today is going to be on what makes the cloud-native ecosystem a little bit unique when thinking about stateful applications. So this is obviously not complete. I think there's a lot of things that you have to consider when deploying stateful applications. But as we go through this, you know, hopefully you get some insight into the different things that you'll have to think about as you deploy your stateful apps. Great. So I'd like to start with the definition of cloud native from the CNCF. So if you've seen this before, hopefully it's not too repetitive. But the basic idea is that this is really the modern way to deploy and use applications. It kind of also captures the idea that these new environments are very dynamic. And often that poses many challenges when deploying stateful applications because of this dynamism. There are many, many projects in this space, so I have an eye test for you. Can you read anything on here? Probably not. I think you know, this slide is a bit overwhelming sometimes, but really what I want to emphasize here is that there's a big community aimed at helping people solve all the different problems you can imagine, right? So across the board, when you're running infrastructure, I think there's something in the cloud-native space that can help you meet your goals. What I also want to talk about is shifting left. So shifting left is one of the fundamental paradigms in this space where you start testing your application much earlier in the development process. This is really important because you find issues earlier and you're able to deploy much more quickly and get continuous feedback from your deployments of your product. You know, this has made companies very successful, and I would say it is actually a requirement of running applications today. You know, we had some great talks today on the implications of security on your applications, and I think shifting left is definitely a requirement these days. Otherwise, you're going to have long-standing vulnerabilities that you need to patch. Right? There's many famous examples in the field of times when people didn't patch their systems, and then they were hacked, leading to very, very bad consequences. In this space, the way that I like to break down on how the cloud-native ecosystem has really changed the way you think about your stateful applications is portability, right? And I think there's some best practices you can follow to ensure that your applications are portable and get all the benefits from that. So when your applications are portable, you really are able to leverage kind of all these different projects in the community that will help you deploy and make your applications robust and secure. When I think about portability, there are really kind of three main components of portability that I would consider. So the first one would be your source code. When you build your source code, right, you want to be able to deploy it somewhere. For the most part, through containerization, this ecosystem has really been able to make your source code portable. So you know, you're able to build containers and run them kind of anywhere. I think the way that this ecosystem struggles a bit sometimes is when you are trying to run your code in environments that don't have different architectures. So for example, you know, running on your Mac locally does pose some challenges. Although I would say that through virtualization, people have been able to run these containers locally during this shifting left in their dev process. Another area to look at is applications. So in Kubernetes, most applications are defined through a common set of APIs. These APIs, you know, we're all familiar with the YAMLs that we've seen for defining what an app looks like. This is really good because it means that I can define these YAMLs in one place and that I should be able to deploy them in multiple environments. However, I would say that the Kubernetes abstractions don't encompass everything your infrastructure can expose. And so in many occasions, there are useful features from your infrastructure. I can give an example. You know, there are snapshots in EBS, for example, that are exposed through the CSI, which is the container storage interface, which is how Kubernetes consumes and exposes storage. And copying between different regions is not exposed through this API. So therefore, if you want to do a copy, which is a very important workflow in data protection workflows, then you will have to go under the covers below CSI, and break the abstraction. And there are many examples that we see like this in the space, where if you really want to do things robustly, you have to break through the abstractions a little bit. And so that's definitely a challenge in the space, which people are working on, certainly. The final one is data. And I think the biggest portability challenge with data is the weight and the gravity of your data. If I have something on my local machine, it's not instantly accessible from somewhere else. And similarly, if I have a machine in the cloud, if I'm using local storage and there's some disaster, I don't have the option to consume that storage immediately from somewhere else unless I put a disaster recovery plan into place, which is very important for running stateful applications. When you think about your applications that consume different types of data, it's useful to frame them as a data service. And when you want to consider moving your data around, the way that I think about it is the different types of consistency you get. So by default, many applications and many databases support crash consistency. So if there's some type of failure, you can go and immediately restore that data. Maybe there's some transaction log that your data service will go and apply, but even if you have a crash, you can come back to some consistent state. That's very useful, but only if you have some isolated failure domain that you don't have to extend beyond. So the other kind of consistency that we describe, which is somewhat new in this space, but I think applies to even legacy systems, is application consistency. And what this means is that you have to coordinate between multiple components in your application. So potentially, let's say your volumes, right, do like a freeze, unfreeze, your data service, so like if you're using like MySQL, flush tables with read lock, to get a holistic view and a holistic crash consistent view of your application. Of course, the most portable thing you can possibly do is capture data at the logical level. So this would be something like doing a MySQL dump rather than grabbing just data from the volumes. Of course, in many cases, this is the only way that you can take backups of some systems. The example that I think of would be RDS in AWS, where if you want to actually extract data and move it to somewhere else, you'll have to take a logical backup of that system. Of course, the Kubernetes community is very active in this space and trying to address all these issues or make it possible to address them. So there's a lot going on in this slide, so don't dig into the details. But this kind of captures a lot of the efforts, most recently, that the Data Protection Working Group, as part of SIG Storage, has been trying to work on. Of course, this group is one of the most popular, SIG Storage is one of the most active and popular groups in the Kubernetes ecosystem. And there's lots of issues that different people are trying to address here. So this slide actually comes from the white paper that was recently published, which kind of gives a scope of what is available for data protection in Kubernetes. And then, of course, the components that are still in progress or missing from Kubernetes, and in some cases don't even make sense to be in a Kubernetes API. The hope is that once all these components have been worked on and are a little more full-featured, you'll have to break the abstractions of Kubernetes a little bit less. But I think the key takeaway here is that there are many things that you'll have to manage on your own or go to a vendor outside of Kubernetes to work with. Of course, there's actually a talk planned today, which I think we have a recording for, so we'll be able to go back and watch online afterwards. But I do encourage you to check it out. It gives an overview of the white paper and dives into more details on what's going on in the space. I wanted to dig into how I think about data protection. And we've all heard the 321, 32111, 32110. It's a little bit overwhelming, and I think the most important thing there is to really think about what that means. And for me, what that means is that you want to mirror your failure domains. So if you imagine that infrastructure goes away, what's your response? How do you respond to that? And so for me, what that means is that you have to do a recovery in light of the fact that some failure domain is not accessible. And I'll dig into what that means a little bit. So people are familiar with traditional cloud failure domains, but I want to talk about what it means inside Kubernetes specifically. So if you have a node and your node goes away, a node is only one component of the state in your system. If I have a volume that's attached to, let's say ephemeral storage or something like that, or local storage that's only accessible from that node, your node goes away, that storage also goes away. And so that would be a case where you've completely lost your data, and you have to make sure that you have backups for that. In most Kubernetes systems, people are using more distributed types of storage. So in AWS, I'll keep using AWS as an example. In AWS, EBS, for example, is distributed, and you can access that storage within an availability zone. In the Kubernetes space, that may map to a single cluster, and if your cluster goes away, you would then lose that, and so you need some other strategy which will let you go and recover that data, even if it extends beyond a single availability zone. Or in the on-prem example, that would probably map to data center. In Kubernetes, there's also namespaces, which are a logical isolation unit. And if you lose your namespace, you may want to just do a local recovery in a different namespace. And so when you take a backup of something within a namespace, having the ability to copy applications is very useful for protecting against namespace losses. Typically, a namespace loss would be something like a operational error, right? I accidentally went in there and I deleted some objects that I need, and so I want to do a test recovery or do some actual real recovery into a different namespace to make sure things work. Finally, as we all know, I think that the scope of Kubernetes is getting bigger and bigger. There's some great discussions today on multi-cluster. I would say that the cluster is actually kind of the final Kubernetes-specific failure domain, and a cluster can only exist in one provider at a time. People are now addressing multi-cloud strategies, which will let you have clusters across different providers, and you want to make sure that you understand the failover mechanism to different providers. There have been cases where entire regions in AWS have gone out, and people want to move between different providers. In addition, I think we see providers in a few terms, right? So even if you're on-prem, for example, doing a failover to on-prem or vice versa in public cloud is also a very useful data protection primitive. I wanted to kind of walk through an example of the different domains with more specifically with a few better diagrams. So what I have here is just a namespace, and you can actually do an in-place restore in Kubernetes. So when you're doing restore, you can overwrite your config and data in place, and that's actually pretty useful for a few reasons. One of those reasons could be I have some critical error and I want to do a rollback. Rollback is pretty common. We see that a lot in people's data protection strategies. It's also useful if you want to do something like you want to roll back Kubernetes versions. So people do cluster upgrades. Sometimes there's some APIs that maybe have changed or are no longer supported, and they have to roll back their cluster and then roll back their data as well because there's some corruption that they might want to deal with. The next kind of primitive that people use is a clone between different namespaces. And this is useful for many different reasons, right? There's a lot of testing things you can do. Potentially namespaces are tied to availability zones. If you want to have more local state, you can do a clone between different namespaces and do your testing or do your failover between different availability zones. And finally, I think the last primitive is between clusters. And when you do a recovery between different clusters, there's many different reasons for that, right? I think this opens up kind of the whole possibility of approaches you can do. You can do copies between different providers, between different Kubernetes versions, between different distributions. I think it all comes into play here. However, with these different environments that you back up and recover into, there are other considerations you need. And the way that I think about this is really to understand the Kubernetes application definition. So you have to do transformations potentially on both your data as well as the application definition. And so it has to be incorporated into how you deploy your app. So if you're using GitOps, for example, GitOps is the thing that contains your entire application definition, and may tailor that definition to different environments. And those environments could be, again, Kubernetes versions, distributions, or even different providers. What's interesting, I think, is that when you do these recoveries, right, you may need to do some kind of transformation between different things. And so, again, as we've discussed today, make sure that this is automated. And so what I have here is an example from a backup and restore of changing something specific to your environment. And this example is actually changing the storage class that you're using. So this could apply to actually any of those use cases I mentioned before, where I want to do an in-place restore, which could upgrade my storage that I'm using. It could be between different providers, or maybe between different environments within the same provider, where the storage class isn't available, or even between different providers, where the storage class cannot even be deployed, so I have to modify it. And the specific example is modifying the deployment spec, the volume claim. And although that is a common API, the parameters you pass in there are not common across all these environments. And so I wanted to leave this open for questions and kind of discuss any challenges that maybe people in the room have faced here, and give, I think we should take advantage of this in-person interaction. So hopefully, you can give me some hard questions while I have this chance. But if not, going once, going twice, awesome. Well, thank you everyone. I really enjoyed today, and I'll see you soon.